How can we prove that current flows from the ground? Because the Earth is, so to speak, a huge capacitor. And if we don't detect any electric current, then there's no wear and tear either.
Hello, dear viewers. Welcome back to our podcast studio. And today our guest is Viktor Tiunov. We will continue to discuss the most important and interesting topics related to technology. Hello, Viktor.
Hello, dear friends. Hello, Alexander. Thank you for inviting me. As a guest, I will be happy to answer your questions.
Well then, if you're happy to, let's get started right away. The first topic I'd like to discuss with you is grounding. It's a very important and fundamental part of the whole mechanism, let's say, of all technology, because it's responsible for restoration. So let's talk a bit more about how grounding technology actually works in practice.
Let's start from the very beginning with how we even came to grounding and why it needs to be used. But again, it's not just us. Let's go back to Rybnikov Yuri Stepanovich. It was he in his experiments, and by the way, it would probably be good to talk about this experiment, because all of this has been experimentally proven and is being used.
Then let's start with some historical background.
Yes, historical background. Yuri Stepanovich Rybnikov, when he was developing his tribogenerator, or rather, not even a tribogenerator, but a tribo-spraying device, his task was to create a device that applies powder coating to the elements being painted. If you can include relevant images on screen of what I'm talking about, it will make the concept clearer for the viewers. So, when he passed extremely fine powders through the tribogenerator, which is a device specifically designed to generate static electricity by friction, and then through the tribo spraying devices, he made an interesting discovery. A constant electric current was being generated as a result of this process. This was a significant observation because it meant that the movement of the powder itself was creating a continuous flow of electricity. Now, if he didn't take the precaution of grounding this current, meaning if he didn't provide a path for the electricity to safely dissipate into the earth, two main things would happen. First, he would experience an electric shock whenever he touched the equipment, which was both unpleasant and potentially dangerous. Second, and perhaps more importantly for the experiment, the entire system would stop functioning properly. Specifically, the device would stop charging the powder particles, so to speak, and as a result, the powder would no longer settle effectively on the part being coated. This is because the electrostatic charge is what causes the powder to adhere to the surface in the first place. To solve this problem, he decided to ground his tribo spraying device. Once he did this, two positive outcomes occurred. First, he no longer received electric shocks from the equipment, making the process much safer and more comfortable to operate. Second, he was able to measure electric currents as high as 200 milliamps, which indicated that the system was functioning efficiently and generating a substantial amount of electricity. As a result of these improvements, the powder began to adhere to the part as intended. However, he noticed that the powder still did not stick as firmly as he would have liked. The part would be suspended in the spraying chamber, the powder would be applied, and a cloud of powder would settle onto the part. But in certain areas, specifically in corners and other hard-to-reach places, the powder did not adhere well. This observation led him to consider another modification, grounding the part itself. The reasoning behind this idea was as follows. He thought that if he was sending excess electricity to the ground, then perhaps the powder particles were being ejected with an insufficient electric charge. If these undercharged particles landed on a part that was also grounded, then, in theory, the electric charges from the ground could help restore the charge to the particles. This, in turn, would allow the powder to stick more effectively to the part, especially in those difficult-to-coat areas, thanks to the renewed electrostatic attraction.
Compensating for the lack of charge,
he tried to make up for the shortage, and it worked. The powder started to stick, and in fact, even if you shook or dropped the part, the powder wouldn't fall off anymore. So these, let's say, magnetic forces, just to make it clear, let's call them magnetic forces, were holding the powder in place. It's like when you rub a stick with wool and then touch it to pieces of paper, they stick. It's the same system here, only the tribogenerator, the tribo charging device, acted as the stick, and the grounded part, the part to be painted, acted as the piece of paper, and the powder would stick to it, so to speak. Then he had the idea, why not try to measure it, since, well, he thought that electrical current was flowing to the part, and that's why it was sticking. He wondered how to check this, how to actually prove that electrical current was flowing from the ground, as he imagined. So he decided, let me put a microammeter there, a device that can measure and show whether electrical current is actually flowing. So he carefully installed a microammeter right between the ground and the part.
And
When he carefully applied the powder to the device really did register an electric current, just as he had anticipated. However, to be absolutely certain of the results, he also had to check and verify it on a wooden pulse tomograph, which is a specialized instrument used for such measurements. This experiment clearly demonstrates that an electric current flows from the ground up to the powder particles and then fixes them in place, thanks to the presence of these electric charges. And it is important to note that electric charge has the unique property of attracting, rotating and repelling, attracting, repelling and rotating. These properties are fundamental to understanding how electric charges interact with each other and with other materials. Well, in other words, electromagnetic properties. Yes. Just to make it clear. That's it. He checked it, and yes, the current really does flow, but there's another point here. A powder particle, that is, which passes through the tribogenerator. You see, everything is interconnected here, so you can't just get away with grounding alone. A powder particle that passes through the tribogenerator, through the tribospraying device, gives up its charges. Charges are pulled out of it, so to speak. It's like we're picking apples from it and sending them through a wire to the ground. If we don't send them to the ground, we get shocked. So we measure it there. The current flows about 200 milliamps, give or take. Now, since we've taken charges from the particle, this is called wear. Wear of the material. The powder particle has become worn out. So how can we prove that it has worn out?
maybe that's exactly why it loses its ability to become magnetized.
No, on the contrary, that's exactly why it becomes magnetized. If it didn't lose its charges, it would repel instead.
That's the whole point.
Yes. So its charges, since it loses electric charges, it wears out. How can we tell that it is worn out? For this, there is another experiment that Yuri Stepanovich conducted on Paul's woodograph. This is a thermal method for studying substances. That is, he took some amount of powder and passed it through a tribo-dispersing device, simply ran it through without fixing it onto a part, just passed it through and collected it. Right? And he took powder that, so to speak, had not been passed through. And this particular thermal method, which we used in our experiments, showed quite clearly that the powder particles that were passed through the tribogenerator had graphs. If you show them, it would be good to display the image here for better understanding, where the particle would ignite or, well, in some cases, melt. In general, it looked as if it was catching fire, almost as though it was burning right before our eyes. This visual evidence, as demonstrated by the graphs and images, really helped us to understand the process in much greater detail. Earlier than the powder particles that hadn't been passed through, the same powder, that is, the ones that had been passed through, ignited earlier than those by several degrees Kelvin. To clarify, when we refer to the powder particles that have not been passed through, we are specifically talking about the original untreated powder. In contrast, the powder that has been passed through the process, meaning it has undergone the tribogeneration step, ignites noticeably earlier, specifically by a margin of several degrees Kelvin, which is a measurable and significant difference. And after the particle had been on the part, this powder particle that flies through the tribogenerator and settles on the part, again, we use this thermal method, and now it already has almost the same ignition temperature as the powder that hasn't been passed through, meaning it restores.
So how was this proven?
Yes, it does recover, but the recovery is only approximately 85%. This was a direct and clear proof that the substance gradually wears out. Not just that the substance wears out, but that the wear and deterioration of the substance is an electrical phenomenon, and if there are losses of electric charges during the movement, if we carefully record an electric current while moving one surface against another, whether it's powder or solid bodies, and we happen to detect an electric current, then there is wear. But if we don't detect an electric current, then there is no wear. That's all there is to it. And the grounding circuit turned out to be very important. A very important aspect in our station, the tribogenerator. And we discovered something. Here, there are only 2 cables connected to the regenerator. The more cables we add to the regenerator, the greater the amount of powder that gets regenerated.
So this also matters? Yes, it
Does matter, of course. That's why the grounding circuit. This must absolutely be carried out strictly, according to all standards and rules. But on a ship, our power station won't work because there's no grounding. And it won't work on a spacecraft either. There you need to use some kind of advanced nuclear technology.
something else entirely, yes.
Well, basically, yes. Like some kind of rare earth metals, such as uranium and other similar elements, are involved in this process and so on. So that's actually about grounding, which is a fundamental concept in this context. It might seem like, well, what's the big deal about grounding? Grounding is just grounding, right? But it turns out that it's actually a crucial and essential thing. Powder recovery, for example, is currently done at about 85% efficiency. And if we could somehow achieve 100% powder recovery, that would be, well, that would already be perpetual, so to speak, meaning it would continue indefinitely. Even as it is,
Even 85 is already a very large number.
of course, we still end up getting electricity cheaper than what we have now, even for our homes. And if you consider the fact that in some places, let's say, for example, there are countries in Africa or even entire villages or settlements, there is no electricity at all. And for them, this would be a real lifesaver.
Laying electricity lines, so to speak, with wires and cables. It's very expensive and costly. Well,
It's better to build a power station there, maybe even a complex of stations, and then distribute electricity from there. So if that answers your question.
yes, of course. But I'd like to delve a little deeper into this topic. In the word grounding, the key part is ground. Have any other sources been considered for restoration? Maybe some new substances, chemical reactions, natural materials, or any alternatives? Why is it just simple grounding and not the use of something additional or supplementary? Could you explain the reasoning behind choosing only grounding rather than combining it with other possible methods or materials?
Well, the thing is, the Earth is a huge capacitor, so to speak. The Earth is, first of all, an enormous, infinite capacitor because the Earth is a closed system. And we can constantly draw from it. And everything constantly returns there as well. That's why it's generally better to use the resources of the Earth. But if we use, let's say, some alternative sources, then those are also finite. That is,
The whole principle is exactly
in this. The whole principle is exactly this. Because we get free restoration. But if we use some sources, some from the outside, right, then that's not quite the same. For example, if we use sources to restore worn-out metal parts, especially large ones, not just powders, but actual chunks of metal, mechanisms, or something else, then that's where it would be useful, yes, if we connect an external power source. Well, in certain modes, of course, you have to set everything up properly, because just like that, nothing will work immediately. You have to go through everything experimentally, carefully adjust each setting, and only then will the system function as intended. For example, there are mechanisms such as pipe benders. These are machines specifically designed to bend pipes of different sizes and materials. For instance, in mining companies, there is equipment that produces what are called strips. These are mining tunnel pipes, but not full pipes. They are not completely closed, as there is an open seam along their length. The rollers that bend these strips tend to wear out very quickly due to work hardening, which makes the metal harder and more brittle as it is shaped, so the rollers themselves get worn out and need frequent maintenance. They are constantly being machined, repaired, or replaced. To address this, manufacturers use bearing steel and other durable materials, but even so, it remains a labor-intensive and expensive process. Now, if you supply electricity to these rollers, well, first you need to measure how much electricity they consume. If you make a device that gives them the right amount of electricity, then there will be no wear. Yes.
Well, there are certain circumstantial costs involved in this.
Yes, you'll need to install metal for the mounting, you'll have to experiment. Yes, no, I don't think there's a high voltage there.
I think some of our viewers would be interested right now to hear about the method of restoring and preserving against wear, creating wear resistance. What is the point, if there is a future in this?
First of all, people need to understand that wear is an electrical phenomenon. And then, from that point onward, you can already begin to derive various methods and approaches for treatment. Actually, not just treatment itself, but also the important process of restoration.
I would like to continue the topic of Earth. After all, we can't talk about the sea, about water, or about space. We are talking about Earth. Does the presence of various impurities in the soil have any effect? For example, this soil is very fertile, meaning it has a lot of humus, so to speak, or it's a sandy, rocky area. Does the content of various components in the soil affect the efficiency of restoration in any way? And is there such a thing as suitable land for placing a container and unsuitable land?
Yes, it affects it 100%. It definitely affects it. Well, again, for example, right? When we were grounding it in our workshop, when I was digging, poking around and hammering it in, basically we did the grounding according to all the rules, just as it should be. But our humidity there is high, even though the soil is pretty ordinary, just regular earth, maybe some clay, something like that, as is usually the case. But it's so moist there, it felt like I almost dug down to the water table, basically, yeah. And we salted it, that is, we sprinkled it with salt. And actually, we didn't even need to do that because we basically made a battery. You know, it started to oxidize.
Ah, right.
And this oxidation reaction produced even more electricity. But on the one hand, that's not really a bad thing for recovery, of course, but on the other hand, the grounding itself kind of dissolves there, so to speak. The metal itself...
So a chemical reaction was taking place, which is not desirable.
Of course, that's exactly why you absolutely have to check the soil first. Usually it's just the most ordinary soil, like regular dirt, clay, and so on. If it's some kind of soft earth or loose soil... But the main principle here is that you really need to dig at least 3 meters deep so that it turns out there were columns, so to speak, grounding. They must be at least 3 meters. And the contour must be connected to each other, welded well. And the tire is brought to the top. If it's sand and everything else, it will all work. In principle, everything needs to be measured here. If the grounding is not quite right for some reason, that is, it's here. Even before installing the container, we do all this.
Preliminary process of studying and taking measurements.
Of course, all this is done. Yes, all this is done. And well, the container is placed where it's favorable or where the grounding can be brought in.
So I think we've just answered perhaps a question some viewers might have had about how the site approval and preparation process works before installing the container. Maybe some people were already concerned about this. Well, and I'd also like to talk about another equally important topic. The word electricity always goes hand in hand with the word safety. And if we're talking about restoration, about the fact that this is a closed cycle, that it operates on its own, how does grounding affect the safety, stability, and durability of the container and, let's say, the entire technology in its closed form?
Grounding here only affects the restoration process, but the station itself, in terms of its internal components, is basically safe. What do we have there? We have a container, a compressor. We have a compressor that pumps air. Essentially, even if this compressor goes out of control and starts pumping air uncontrollably, then the air ultimately ends up in the receivers, in the storage tank. But the receiver will start releasing it. It has a mechanical valve that will simply vent the air, and it won't be able to build up any more pressure. And the grounding itself is only needed for restoration. That's basically it. Everything else is handled by the tribogenerator. What can be dangerous at the station, and what you really need to be careful about, is the inside of the tribogenerator itself. There are certain dangers and risks present there, so it's much better, and actually highly recommended, for an untrained person, someone who does not have the proper experience or technical knowledge, not to touch it at all. If you are dealing with a 3D transformer, it's more or less safe, relatively speaking, because it's already been prepared, set up, and so on, with all the necessary safety measures in place. However, with the tribogenerator, if it's running, operating, or in use, it's much better, and actually safest, not to even go near it, let alone try to interact with it or touch it in any way.
Safety precautions. The principle of grounding. It is necessary so that part of the electricity doesn't harm the system, but instead is diverted away, or conversely helps restore it. So how is the process arranged so that not all the electricity just goes to waste, as they say, but is returned to power the system?
Here, nothing goes to waste at all. Everything is used for the operation of the system. We have a special electricity distribution system. That is, of course, we are planning to improve it. Right now, it's, how should I put it, kind of from the Soviet era, let's say, it's all mechanical. So at the moment, we switch everything manually. Of course, all of this needs to be computerized so that you can control the power plant from an app and so on. But I think our guys, like Saligi from Saudi Arabia, they have this experience, and in principle, they can help us with this. As for our power plant, when we talk about 16 kilowatts, in reality, it produces 32 kilowatts, and 16 kilowatts out of those 32 are used for the operation of the station itself, for maintaining the station's own functioning.
For self-sufficiency,
of course, it absolutely needs to be cooled to maintain the proper temperature, and if it gets cold, it needs to be properly insulated, right? Then there has to be sufficient lighting, and dehumidifiers must be running continuously to control the moisture levels, and they also need to be connected to the system. The backup batteries need to be charged regularly. The system itself in these cabinets has to work reliably, and the distribution as well must function properly. So after all of these essential requirements are met, we only have 16 kilowatts left that we can actually give to the consumer. And if there were no consumer at all, we would just send that energy into the ground. That's all there is to it. So there's nothing extra there. Everything is put to use. Everything is interconnected, and everything serves a specific purpose in the overall system. Every component, every device, every connection is necessary for the operation. All of these elements work together to ensure the system functions as intended, with no waste or unnecessary parts.
dear viewers, thank you very much for being with us. Thank you for your attention. You can leave your questions in the comments and we will try to answer them. And today our guest was Viktor Tiunov, and we were uncovering the secrets of technology. Thank you very much, Viktor.
Yes, thank you, Alexander, for inviting me. I'll definitely come back again if you invite me, of course. And thank you to everyone who was with us today and watched our podcast. Be sure to write your questions. I'm very interested. I read them and we will definitely answer them. Thank you.
See you in the next episode.